Chapter 10, Lesson 1, Circles and Circumference. Begin with vocabulary. Circle is the set of all points in a plane equidistant from a given point called the center of the circle. So here's a picture of a circle with our center. And again, the definition is the points that are all equidistant from the center of the circle. We typically label the center with a letter as it is a point. So I would call this circle with center P. And using symbols, that's a circle with a dot in the middle and then the letter of the center point. So again, this is the symbols for circle with center P. There are special segments that lie within a circle. 3 of those segments are radius, chord, and diameter. The radius is a segment with endpoints at the center and on the circle. This is an example of a radius, the segment whose center is at the center and on the circle. Okay, a chord is a segment with endpoints on the circle. Okay, here's an example of a chord. Both endpoints A and B lie on the circle. Okay, diameter is a chord that passes through the center and is made up of collinear radii. Now keep in mind the definition of a diameter is a chord because the endpoints of the chord lie on a circle and the endpoints of the diameter also lie on the circle. So a diameter is a special chord. What makes the diameter special is that the chord passes through the center of the circle and it's created with 2 collinear radii. In example number 1, we're going to identify the parts of a circle. So first we're going to name the circle, and we name the circle by identifying the center. Our center is X. So I would name this circle with center X, which has the following symbols. Circle with center X. Next, we're going to identify a radius. Okay, there is more than one in the circle, so I can pick just one. A radius is a segment whose endpoints is at the center and on the circle. An example of a radius is segment XV. These are segments, so we have to use appropriate symbols. Another option, segment XU, has an endpoint on the center at X and on the outside of the circle. Okay. Those are 2 examples of a radius. Next we have a chord. A chord is a segment whose endpoints lie on the circle. One example of a chord is segment RS. Both R and S lie on the circle. The diameter is a chord that passes through the center, so my diameter is segment ZT. Okay, when you're ready, turn the page. Radius and diameter relationships. Okay, a radius is half of the diameter, or the diameter is 2 times the radius. In example 2, letter A, says if segment TU equals 14 feet, what is the radius of circle with center Q? Now, segment TU represents a diameter. Okay, I know that a radius is half the diameter. So the radius I could find by multiplying 1/2 by the length of the radius, 14. So the radius of this circle would be 7 feet. Okay. I would like for you to try letter B. Okay, when you're finished trying letter B, move on to the next set of examples. Okay. Now, to review radius and diameter relationships, radius is 1/2 of the diameter, or the diameter is twice the radius. We can use the radius and the diameter to find the circumference of a circle. The circumference is the distance around the circle. It's kind of like the perimeter, but we give it a special name because it's a circle. Circumference is found by multiplying 2 times pi times the radius. Okay? Or, since we know that twice the radius is equal to the diameter, we could also use circumference equals pi times d. Pi is a number. So in example number 4, it says give an exact answer and round to the nearest hundredth. So in letter A, we're going to find the circumference of the circle if the radius is 2.5 centimeters. Okay, if I'm given the radius, I'm going to use the formula C equals 2 pi r. I want to find the circumference to the nearest centimeter. So I'm going to take the circumference, what I'm trying to find, I'm going to multiply 2 times pi times my radius, which was given at 2.5. To give an exact answer, we do not plug pi into our calculator. Although pi is a number, we're going to treat it like a variable. I'm only going to multiply the numbers. 2 times 2.5, that's 5. So the circumference is equal to 5, and we're going to attach the pi on the end. So circumference is 5 pi, units are centimeters. This represents an exact answer. I'm also going to be asked to find an approximate answer. Okay? Now, an approximate answer is an answer that's going to result in a decimal. So if I take C equals 5 times pi, I'm going to plug that on in my calculator. I'm going to take 5 times, now pi is approximately 3.14, but we want more exact. So we're going to use the pi button on your calculator. Okay, when we hit equal to, we get a long decimal, 15.70796327, and it actually keeps on going forever. Okay. Okay, I'm going to round this to the nearest hundredth. So I'm going to say C is approximately, it's a squiggly equal sign, means it's an approximate. It's close to the right answer, but not exact. To the nearest hundredth is 70. The number after is a 7, so I'm going to round 70 up to 71. So this is approximately 15.71 centimeters. Okay, I would like for you to try letter B. Find the diameter and radius of a circle if the circumference of the circle is 77.8 centimeters. Pause the video and try it. We will go through and check it in class. Okay, when you're ready, let's turn to the next page. A polygon is inscribed in a circle if all of its vertices lie on the circle, and a circle is circumscribed about a polygon if it contains all the vertices of the polygon. In example number 6, we have an example of where a circle is circumscribed about a polygon. So each vertice of the triangle lies on the circle. It says the right triangle shown is inscribed in circle with center D. Find the exact circumference of the circle. Now, in order to find the circumference, we can go C equals 2 pi r, or we can go C equals pi d, where d is the diameter. I do not know the length of the diameter, but I was told that this was a right triangle. Right triangle has a right angle. And I can find the diameter using the Pythagorean theorem because I know 2 of the 3 sides. So to find the diameter, I can take 8 squared plus 12 squared is equal to my diameter squared. 8 times 8 is 64. 12 times 12 is 144, and this is equal to d squared. Okay, on our calculators, we're going to take 64 plus 144, and we get 208. To go from d squared to d, I'm going to take the square root of both sides. Now, if I take the square root of 208, I do not get an exact answer, and I was asked to find the exact circumference. So I need to simplify the radical. I need to find the largest perfect square that divides into 208. So when I think of perfect squares, the numbers I can take the square root of. I can take the square root of 9. So if I take 208, divide that by 9, that does not work. I can take the square root of 16. So if I take 208, divide that by 16, I get 13. That works. So I know that I can write 208 as the square root of 16 times the square root of 13. Square root of 16 is 4. I cannot take the square root of 13. So an exact answer, my diameter, is 4 radical 13. So I can plug that in to find the circumference. Circumference equals pi times 4 radical 13. When we give an exact answer, we always put the number first that we calculated. So I would write this as 4 radical 13 pi. Okay, and these are in centimeters. This is an exact answer. If I wanted an approximate answer, I would plug it in and get a decimal. Okay. Okay, letter B. A right triangle with legs 7 meters and 12 meters is inscribed in a circle. Find the exact circumference of the circle. Okay. So I'm going to draw a circle. Now it says a right triangle is inscribed in a circle. So here's my center. I'm going to draw a right triangle. Okay, the legs are 7 and 24 meters. So this side is 7 meters, this side is 24 meters. Find the exact circumference of the circle. Again, I can find the diameter. So I'm going to use C equals pi d, but I have to find the diameter first using the Pythagorean theorem. I know that 7 squared plus 24 squared is equal to my diameter squared. 7 squared, or 7 times 7, is 49. 24 squared, or 24 times 24, is 576. This is equal to my diameter squared. So I'm going to take 576 plus 49. We get 625 equal to d squared. To get d, I take the square root of both sides. And if I take the square root of 625, I get 25. This one works out nice. So my diameter is 25. So to find the circumference, I take pi times my diameter. My diameter was 25. When I write a final answer, I put my whole number first. So C is 25 pi. My unit of measures is meters. This is an exact answer. If I wanted to get an approximate answer, I would plug it into my calculator. I would like for you to try letter C. Okay. Following the you try, you are finished with your 10.1 notes. I would like for you to upload your completed notes to Canvas. Okay, the 3 you try problems need to be complete to the best of your ability, and then we will go over those 3 problems in class at the beginning when we meet at the end of the week. Good luck.